Today we are going to carry on with some exercises on Chapter 16, Electric Forces and Fields. Question 1. What determines the direction of electric force between two charges? And the answer is the sign of the charges. The gravitational force is always attractive, while the electric force is both attractive and repulsive. What accounts for this difference? Mass is positive, but charges are positive or negative. When more than one charged object is present in an area, how can the total electric force on one of the charged objects be predicted? Each force exerted on an object is found, and then the forces are added together vectorially. Question 4. Identify examples of electric forces in everyday life. In everyday life, we can find many examples of electric forces, but the ones which we are going to mention are the force between hair and a comb, or the force that acts when people receive a shock by touching an object. Question 5. According to Newton's third law, every action has an equal and opposite reaction. When a comb is charged and held near small pieces of paper, the comb exerts an electric force on the paper pieces and pulls them toward it. Why don't you observe the comb moving toward the paper pieces as well? We don't observe the comb moving toward the paper pieces because the comb has a significantly greater mass, so its acceleration is much less. How are conductors different from insulators? Conductors transfer charge easily, insulators do not. Question 7. Would life be different if the electrons were positively charged and electrons were negatively charged? No, it will not be any difference because positive and negative are arbitrary designations. Because of a high moisture content, air is a better conductor of charge in the summer than in the winter. Would you expect the shocks from static electricity to be more severe in summer or winter? Explain your answer. The shocks from static electricity are going to be more severe in winter because more charge can accumulate before electric discharge occurs. Question 9. Which effect proves more conclusively that an object is charged? Attraction to or repulsion from another object? Explain. Repulsion, because attraction can be the result of an induced surface charge, but repulsion occurs only when two objects each have a net. Question 10. When a conductor is charged by induction, is the induced surface charge on the conductor the same or opposite the charge of the object inducing the surface charge? Is going to be opposite. Question 11. What is an electric field? An electric field is a region where an electric force on a test charge can be detected. Do electric lines actually exist? No. Electric lines actually they do not exist. They are just a tool used to visualize and analyze the electric fields. Question 13. When defining the electric field, why must the magnitude of the test charge be very small? So, the test charge does not significantly affect the charges responsible for the field. Question 14. A free electron and free proton are placed in an identical electric field. Compare the electric force on each particle. How do their acceleration compare? Electric forces are equal and opposite. The proton's acceleration is less because it has a greater mass, and as you see here is the second Newton's law, force is equal mass times acceleration. The acceleration is inversely proportional to mass, so as the mass increases, the acceleration decreases. Question 15. When electric field lines are being drawn, what determines the number of lines originating from a charge? What determines whether the lines originate from or terminate on a charge? The answer for the first question, what determines the number of lines originating from a charge, is magnitude of the charge. And the answer for the second question, what determines whether the lines originate from or terminate on a charge, the answer is sign of the charge. Question 16. Consider the electric field lines in the figure below. Where is the charge density the highest? Where is it the lowest? If an opposite charge, the question B, if an opposite charge were brought into the vicinity, where would charge on the pear-shaped object leak off more readily? The answer for the first question, where is the charge density the highest? The answer is where curvature is greatest. Where is it the lowest? Where curvature is least. And for the question B, the answer is going to be where curvature is greatest. Question 17. In which way is the electric force similar to the gravitational force? Electric force decreases in strength as the distance between the charges increases. Similar to the gravitational force, it happens the same even to the gravitational force. What must the charges be for A and B in the figure below so that they produce the electric field lines as shown? As you see here, the lines are going in the charge, so they terminate to the charge. We said that if the lines terminate to the charge, this charge is going to be negative. So the answer is A and B must both be negative. Question 19. A negatively charged object is brought close to the surface. This is the object, and this is the surface of a conductor. The opposite side of this conductor is grounded. Question A. What is this process of charging called? This is called charging by induction. Question B. What kind of charge is left on the conductor's surface? Here, this part here, positive charge. Question 20. If a suspended object attracted to another object that is charged, can you conclude that the suspended object is charged? Explain your answer. Not necessarily. The suspended object might have a charge induced on it, but its overall charge could be neutral. Question 21. In the figure shown below, why do only half of the lines originating from the positive charge terminate on the negative charge? And the answer is because the positive charge is twice the magnitude of the negative charge. As you see here, the positive charge is plus 2q and the negative charge is minus q. So is double charge. Is the charge shown in the figure below positive or negative? Based on the lines, they are going out from the charge. We say that this charge is positive. Question 23. What occurs when two charges are moved closer together? The force between the charges increases. And this was the last question for this review about chapter 16. Thank you for watching.